I'm Marjie. I'm Marjie Welchframe. I am your guide to the universe tonight.
Okay.
And it is Monday, September 15th. So I have a list of people who are going to speak. Wyman is going to speak about the Canadian Radio Telescope in Penticton. Dave Payne perhaps has a photo or so. Randy will speak about Polaris and has announcements. Reg will speak, Natasha and Chris Gainor. Is there anyone else who would like to be on the list? All righty. So we'll do it in the order that it was given. So Wyman, would you like to begin?
Yeah, sure. So I guess it was last year when we were on a car tour and we came across a building right in the middle of nowhere, right? And we were just shocked on the size of this unique building. It's a giant satellite dish in the bottom of a valley. We're surrounded by mountain ranges, right?
In Penticton.
In Penticton. You're 24 minutes from Penticton on the highway.
Okay.
Yeah, and I said, gee, if we get to come back in this area, we got to stop by and be a great photo op, right? So because it looks so scientific and radio telescope, so I put two and two together. Wow, somebody in the DAO here must know something about it. So I got in touch with Lori and she said, oh yeah, that's part of the DRAO, radio telescope installation things, and I said, okay. And so I said, okay, we're planning again to go again this year. So let's see if we can contact the person in charge. Like, can we get really, really close to it, right? Because most of these installations are so official looking. They keep you miles away and, full of sentry guards with guns and everything. And Laura said, no, it's a public, it's open to the public. You just email the guy and I'll email them on your behalf. And you said, yeah, just make tell them what day you want to come and they'll accommodate you. And so I said, okay. So we made that part of our itinerary. In our car club, we went for a 5-day tour of the interior. You go to the spas, the resorts, the wine tasting, and I put this one little stop off area, almost like the second to last day of the ending tour, right? And so we had 13 cars, so we all trucked in. So let me share my screen. Let me figure this thing out. Share screen. Screen broadcast, I guess. Start broadcast. Hang on. Huh. Everything in your screen, including, will be recorded. Okay.
I think that's okay, Wyman.
Oh, okay. So let me go to, I know. Oh, no. I thought I could share my screen here. Screen, it says screen. Start.
So, Wyman, I did download the photos if you want me to put.
No,
You got it.
Is it going?
You got it.
Okay, share screen.
I think you've done that.
Do you see anything?
I don't see anything though.
Huh.
Sharing the screen.
It's tricky with a tab with an iPad.
Oh, really?
It may be better if Randy shows them.
Oh, okay. Yeah, the first screen was show the website of the installation. Oh darn it! The thing worked when I was testing it. Without joining the thing, the whole thing worked and everything.
I think we have numerous people that have your photos. So
okay, hang on. Share camera, share item.
Oh, this is good.
Let's leave more promising.
Got a white screen.
But
No?
there's nothing there yet, no.
How do you normally display your photos, Wyman? Do you just go to the photo area?
Yeah, just go to the photo area.
Mm-hmm.
I'm just trying to go get a Google here to show you the website of the actual site. Yeah.
Wyman, it looks like you have some dots beside an area that says Wyman's iPad screen. Maybe it has some options there.
Okay. Full screen. No, it's all there. Oh, geez.
Wyman, Randy or David can do it if you want to make it easy.
Yeah,
Okay.
sure. Okay.
Okay, I'll take over.
Okay.
Okay, but you have to unshare.
Yeah, let go of the screen.
Unshare. Okay.
Yep.
Stop share. Okay.
Okay, so I share, and here is the
Okay.
screen.
So that's the website. So Dominion, that's from, okay. So it's located in Westlake, Caledon, which is about 24 minutes down the highway from Penticton. Pretty easy drive. It's a beautiful drive. So in 1959, this 85-foot diameter satellite dish was built. In 1957, the first director was hired, right? So he was hired before the thing was actually built and finished. So the guy that was the first director, his name was John Galt, G-A-L-T. And here's the funny thing. In 1952, he was here in Victoria at the DAO. He was working on the first photometric sensor. So yeah, so that's the building, and that's the satellite, the radio telescope, and that's with the CHIME, I think that one. So there's basically three types of observation system on that big area. I mean, there's way more arrays there too now. I mean, just acres and acres of machinery. So here is when we first pulled in. We parked all our cars there, right? Yeah, you go into to the next one. There are more cars. Go into the next one. Yeah, keep flipping, keep going. All the cars lined up. Next. So the guy in blue is Wendell. He was our tour guide. He's an excellent, enthusiastic. Explains everything. It's quite an incredible place. You know, when we all arrived there, first thing he tells you, okay, everyone's cell phone, power it off. Not airplane mode, just turn the darn thing off. Because even in Mars, if your phone is on airplane mode, it will see it. And you see all those mountain ranges? All around is mountain ranges. So that idea is to shield this installation from extraneous radio waves.
But you could use your camera. They weren't bothered by
I
the
was the only person with a freaking camera. See, if I wasn't there, there would have been no pictures. You don't know until you get there. Shocking. Because I don't know how to turn off a cell phone, you know, and leave your camera on.
You can.
It's always pinging or some crazy thing. Yeah. Yeah, keep going. Yeah, and we get closer and closer. I kept me going. Yeah, so you explain about the area. We had 26 of us. I think that in total, there's only 74 people that were scheduled to come. It's free. You know, it's amazing. This place is free to attend. Yeah, you walk right up to it. You almost touch it. I don't think it was working that
interested
day.
in the
He's pointing
mount.
at the bottom.
Is the mount equatorial? It's hard to tell.
Yeah, the whole thing pivots and everything. So this telescope, then it was not named until 2014, because for the long-term director, John Galt, it's finally dedicated to him in 2014. So here's the visitor hut. Like, it's full of displays, a little miniature classroom. I mean, it's phenomenal. It's a great place to visit. Outside, solar scopes, and
Is that a counterweight?
I'm not sure.
Not
Probably
very big for something that big.
is. Yeah.
Not bad if it's full of lead.
Yeah.
So the classroom, lots of stuff to see. He was so funny. He's such a humorous guy. He just captivated the audience. Now, don't forget, this is like the fifth day of our 6-day tour, and we've been to all the neat places already. And of all the places we've been on the 6-day tour, the whole thing, this was the most memorable part of the whole trip.
You can usually drive into those.
It's quite amazing.
Was it staff or was it volunteers doing that?
They're all volunteers.
Wow.
Yeah, Wendell was excellent.
Yeah,
I think he was explaining quasars to us and super black holes.
Wendell gave a monthly meeting talk in 2017.
Hmm. Hey, you should think of inviting him for a Zoom meeting. So here's our group photo. He let us drive one of our cars right close to it. So I'm hoping this becomes our cover page when I submit it to the Astronomy Global magazine. Hope it get published, because I hate it when the other chapter of Astronomy, with all their castles in England, and they got us beat. But I bet they don't have one of these puppies sitting in the background. So
Hey, Wyman.
yeah.
Can you just remind me? Did you just show up spontaneously and have the tour? Or did
No,
you have
well, you could show up spontaneously, but I made arrangements before, because hey, look, we have the car club coming, and I really want to park really close to your radio telescope. And Wendell was so accommodating. He moved his truck out of the way. His truck was blocking the pathway. Yeah, bring your cars in. So we just picked one car to make it quick and easy.
So you guys just arranged this?
Yeah.
The tour. Okay.
Yeah, and anybody can go. It's surprising, and they don't have that many people. I'm just shocked. Such a great facility, and well, we were there. We were a shorter time. We were only there for an hour and a half. I think we could have spent another hour and a half easy, because we didn't. He didn't talk about the other telescope equipment yet. Maybe we had more time. Maybe I'd give it a tour inside the building too. I don't know, but we were just outside and in the visitor area. But it was a beautiful day. I mean, you look at it, right? It's just shock and awe. How often can you walk up to a national monument like that and get really close? Yeah.
Wyman,
Yeah.
now with bigger telescopes and all that, is this telescope obsolete, or is it still doing
No, they
good
have
science?
upgrading all the electronic every year, so it's still heavily used. Yeah, it's amazing.
CHIME is relatively new. That's the really big, long one. That I don't know if there was a photograph.
Well, there's this photograph. Come back.
Yeah, that one.
Oh no,
Yeah.
no, that's only a little
No,
bit of
that's-
chime.
Oh, there's more.
Yeah.
They expanded that.
That
little-
must be an old photograph.
Yeah.
That's a Pathfinder, Chime Pathfinder.
Yeah, that's not CHIME.
No.
Time is in front between the main building and the road.
It's long.
Okay, yeah.
This long one, that long one.
No, that's not chime.
Yeah.
Oh, no.
Chime looks like a bunch of ski half pipes.
That's a very good interferometer, that one. That's pretty good. They use that a lot.
Wyman, it's
Yeah.
Marjie. Will you be able to tell us what each one of those pieces of equipment is for?
I can't. He only explained about the first one, the big telescope. I thought he said that the big wave telescope confirmed where our solar system was positioned in the spiral arm of the Milky Way. I think that's what he said. Because no one really knew where exactly, and I think this thing mapped out the hydrogen. I don't know, the crazy map of where where our solar system was.
Well, it's good that you stopped and wowed all your fellow car club members.
Yeah.
With a bit of radio astronomy, which they probably hadn't thought of.
No, I know. The one thing you get out of it is, wow, you get so proud to be a Canadian. Like, heck, it was big. Back in 1959, you think about it, we had the Dominion Plaskett, we had this. It's shocking where we are in the world for Canada.
Well, with CHIME being there, it's also very current because CHIME is on the leading edge. Actually, other countries are starting to emulate the NRC's efforts with that type of a detector because it's playing right into current research.
Mm-hmm. Yeah. Yeah, it's a great site. I encourage you guys, try and visit. It's really cool. I mean, that's probably a great site to view the Perseid meteor shower, nice and dark and flat. Have a star party there.
Brian Chappell, can you talk about what you just wrote there?
Oh, yeah, in that photo of the visitor center, you can see there's a small in the background, looks like a satellite dish. I think it was kind of goldy colored. It's about, I don't know, just meter in diameter or so on. I think this is still true that like every day, and more times a day, there are people who what's called space weather, what the sun is doing, how it's interacting with the Earth. And one of the most baseline of measurements is the solar flux. It kind of serves as a proxy for a sunspot number, as it's fairly well correlated. And it's measured at a frequency of 10.7 gigahertz. And that humble little telescope is or at least was the global source of that data. And other things are measured with spacecraft and magnetometers and key locations, but unless they've moved it, there it is, kind of just behind the lamppost.
Yeah, that's Wendell explained to me that has been in operation for decades and decades,
Yeah.
and it's the one that has the most data of any detector on Earth as far as space weather for the sun is concerned.
Yeah.
Pretty remarkable considering it's such a small little dish, but they've kept it running all these years.
And can one of you just remind me what CHIME does?
Chime looks for hydrogen, and what they're also using it for right now is for fast gamma ray bursts, I think, as well. So it's actually evolving what they're using it for. It's very nice that it's actually been able to start looking for things other than it was designed for. So it's a very, very unique instrument.
Margie, if I could interject, CHIME Canadian Hydrogen Intensity Mapping Experiment, and the primary mission is to try and measure the expansion rate of the universe, and they've got a very innovative way of doing that. The fast radio burst was kind of tagged on, but it became so successful and so interesting that they put a smaller version of the CHIME antenna in West Virginia, Green Bank, another one down in California, and they're putting another one a little ways further north of the valley that CHIME is in now, so they can triangulate and get more accurate estimates for the distance and location of these fast radio birds.
Thank you.
Yeah.
If I can interject here a little bit, there's a lot we don't know about, the people don't know about DREO. When I started to work for NRC after I sold my engineering company, I spent some time up there. These folks are very talented in the radio astronomy area, the local folks as well as the folks up in Penticton. The folks in Victoria here make some of the very, very sensitive detectors that the radio telescopes need. They're one of only a few people in the world that do such a good job of it. And many of our scientists and engineers end up managing the sites down in Chile, or Chile, as they say. Like, for example, ALMA and some of the other radio astronomy places. So Canadians are very, very well represented in the radio astronomy world, both technically and managerially. So it's something to be proud of, but you never hear about it.
I might be incorrect, but I think that large John Galt telescope was used in conjunction with radio telescope in Algonquin Park to make the first long baseline interferometer experiment to measure high resolution radio telescope stuff. And they did that by synchronizing atomic clocks. I know the NRC made a really interesting, or the National Film Board made a really interesting show about this, and it was a source of pride for Canadians way back in the 1960s.
If I could just
If
I could just add to the story, like on the CHIME, hydrogen, even though it's so abundant, is very hard to see. Like the only time we can see it with a camera is when it's giving off that hydrogen alpha part. Otherwise, it's almost completely invisible, except for this weak 21 centimeter wavelength when the electron turns its spin. But it's very exact, that line. So by counting the intensity, they can figure out how much hydrogen atoms are in a given place. And then from the redshift, from that 21 centimeter wavelength, they can determine how it's moving relative to us. And that goes back into the expansion of the universe calculation.
There's another tidbit about DREO. They're very good at doing electronics up there. About 15 years ago, I was working with some folks up there that were developing something on an FPGA board that was going to be doing all the signal analysis for ALMA and also for the big one, what was it, the square kilometer array, the SKA array. These guys are uber talented, but what's happened now is they're also going to be using this on the TMT. All the technology they developed for the TMT is now obsolete because we've been sitting around for about 10 or 15 years trying to sort out what's going on. So a whole pile of time and effort has been wasted waiting for the resolution of where they're actually going to put TMT, which is really too bad. I just found out this, I hang out with a guy named David Crampton a bit now, and he was telling me all this kind of stuff. He used to be one of the senior astronomers up there.
Thank you all. Thank you very much, Wyman.
Yeah, no, hey, I just sent a link to Joe, David, and Randy. More information about John Galt, his history profile. It's fascinating. Like he's been around the world in training for this job, radio telescope. He was in England, up north, Algonquin. He's been in all those places. So I don't know, maybe Joe or can put the link so people can check out the biography of John Galt. Fascinating guy, especially when he has a footprint at our own DAO. Kind of neat guy.
Great.
Wyman?
Yep.
Thank you, Wyman.
You're welcome. It was great.
Randy, would you like to present information on Polaris, please?
I think I'd like to do announcements first and then
Great.
do that. And the
Terrific.
first announcement is that we have swag. So we have these lovely t-shirts, and I have to tell you, we still have a number of small, medium, and large. This is the last extra large, and it's got a piece of tape on it that says Jim Cox. So this is to shame you so that you actually come and pick it up. And then we have these, what we're supposed to be, in my original idea, would be just presents for speakers, but several people said they want to buy them. And so the t-shirts are $25. And I think what I'm going to do is, if it's small, medium, large, then we have some. But I'll take specific orders for extra large and double XL, which we didn't order because there were several people who were wishing that. And so we'll actually do a special order of XL and 2XL. And then we have a whole bunch that, you know, they don't go bad, but it'd be nice to not have the inventory. So contact me, pastprez at victoria.rasc.ca. If you want small, medium, large, no problem. And then at some point, we'll do the extra large and 2XL order. And $25, $35 for the whiskey glasses. Okay, next, we don't have our president here, so I'll just say you have an email saying that there is a council meeting tomorrow on Zoom, and everybody is welcome. Sorry. Okay. Couple of other small announcements. So let's share the screen. And my Facebook this morning said that yesterday was the anniversary of birth of John Lowry Dobson. And I think that's something we should all remark. He was very important in democratizing large telescopes by designing this very simple mount. And he apparently was really, really good at sitting out on the street and showing off interesting things in the sky. So definitely a leader in the amateur astronomy world. So that was yesterday. But another thing, yesterday was an anniversary, and again, this was in my Facebook today, is the 10th anniversary of the first detected gravity wave.
God,
And
10 years.
it was like a real change in how we get to probe the universe with this event that happened 10 years ago yesterday. And I don't know, I've never seen this picture before, but this is what it looks like in Washington State. And this is what it looked like in, I think that's California. Is it? Who knows? Where's Livingston LIGO? Anyway, you can put them together and they are shifted. Oh, it doesn't say here, but it's something like 7 milliseconds, or was it 7 microseconds? So they're the same, but different. And I love that. Okay. Now, the next thing I was going to tell you, I would have had egg on my face. But I want to say that, yes, now there is this, it's going to be a regular thing on the website. So victoria.rasc.ca with this icon will be the monthly what's happening this month, and it's what's happening in the club, but also what's happening in the sky. And I said everybody should get up to watch at 3:30 in the morning the moon going past Venus. And this was little screen dumps that I took off of what do you call it? Stellarium. And just before coming this evening, I was just checking where would be a good place to watch this when I realized that the moon doesn't rise till 4:30. So it'll still be really nice Friday morning, but I think if I wake up in time, I think I will go to watch moonrise at 4:30 at King George Terrace. And if anybody wanted to join me there, that looks like about as good a place as we've got, given exactly. It's going to rise just a bit north of east around 4:30 in the morning. And, you know, here's Venus, here's the moon. So it will be within one moon diameter as it's rising. And it might be a really good photo. So I hope that I can show you that someday soon. Okay, is that all my announcements?
Actually, Randy, I
Yeah.
wonder if this would be a good time to. I did mention algal observations
Oh, go for
during
it.
the monthly meeting, and I thought I mentioned it again because it's coming up. In fact, September 19th. So the minima is happening at 11:12. Let me just share my screen.
Who needs sleep?
Who needs sleep? Yeah, exactly. So let me just go back. I'm just going to change the mag here. So everybody knows that Algol, the demon star, is an eclipsing binary, right? So the whole point of doing these observations is to see a demonstration of a variable star, in this case, an eclipsing binary. So if you know where to look, just underneath of Cassiopeia, you'll see this chain of 3 stars here, with Merfac being in the middle. And then off of this, you'll see Algol. And I'm just going to zoom in a little bit. You have to do a little bit of homework in a way. To begin with, you have to be there. But so let's just have a quick look here. So we're going to do something called differential comparison. So this is kind of like visual photometry. So rather than using a photometer or using a camera, we're just doing this by eye. And a number of you have already done this, so it is possible to do. So if you look for, this is Algol right here. When it's brightest, it's a 2.1. And that makes it a perfect comparison star. LMAC makes a perfect comparison star at 2.17. So this one up here. And it's very close by. And then when it dips down to 3.4 during the minima, then this guy here, Kappa Persei, is 3.8. So again, really, really close. So the idea is when you get out at these different times to look, and here, this is a strategy. So those are the comparison stars I mentioned. But what you do, in fact, Jill asked me this question when I resent the information to the beginners group. It takes a 10-hour period from bright state to bright state. So the minima, so for instance, here on September 19th at 11:12, that's the midpoint. So that's when it's faintest. So there's a bright state dimming down to meet the faintest point, which is the minima. And then from the minima, it starts to brighten up until it becomes fully bright. So that end to end is 10 hours. So approximately once you see the minima, it takes about 5 hours before it gets bright again. Now, I suggested to people that you might not want to do it in one day. You theoretically could, because I guess in theory it still should be dark. But if you want to really see the effect of it, you might want to wait until the next day. And the next day is well beyond that. time period, and it won't be close to the next minima. So that's one way of doing it. Or you can go early. David, you have a question?
What's special about September 17th, 19th, and 22nd?
Those are also minimas.
No.
So you have a choice.
Does
You
it
can
happen
choose.
all summer or?
It happens at inconvenient times. I think when Jill mentioned this, I looked for a time that was convenient, right? Because I mean, some of them are really awkward times. Like I don't know, maybe if you're up at 223, you could witness a minima there. Or the 22nd is actually not a bad one. That's 8:01, but I don't know if that's really fully dark yet. So 11 seems to be the most reasonable one.
So is
Yeah,
there?
it happens all the time, David. I mean, it's
Okay.
every 2.97 days there's a cycle, but there's obviously during the summer it's not very convenient because we don't have very many dark hours. When we get into the time where we have more dark hours, then the weather gets bad. So this is kind of like an optimal time to do algol. So that's why I suggest it. And if you have any questions beyond this, just let me know. Great, thanks, Randy.
And I think the forecast is going to be fantastic this
No,
week.
it's really good, and I hope Reg will stick his neck out and say it's going to be wonderful for the next few days.
It's not a clean bill of health, but it's very good. And Mount Baker is visible now. First time I've seen it in about 4 weeks, 3 or 4 weeks.
So you might be convinced to say promising. Maybe not even promising.
Not entirely out of the question. What about that?
Yeah. Anyways, that's great. I hope the skies do remain clear so we can do different things.
Thank you for
Okay,
those.
shall I continue, Margie?
Oh, yes, Randy, now you can do your
Okay,
Polaris presentation.
here we go. Share. And F5. No. Function F5. There we go. Okay. So yeah, we're starting with the spectacular picture of John McDonald's, and I actually have a print of this in my basement, but I couldn't take a good picture of it in situ because the reflections were too bad. So this I got off the Zenfolio, but I believe he took this picture during the Winter Olympics. Does anybody know about his picture? But all these are airplanes down here. This is, I don't know, probably 6 hours of exposure.
It's more than 6.
That's more than 6.
Yeah, he
guess
took
so.
that from just south of Nanaimo. And
Right.
yeah, there was fireworks going off and all sorts of things that night across the water in Vancouver.
Joe, correct me if I'm wrong. This must be a set of successive exposures. It's not a continuous one, right?
Well, you can see that.
Am I correct?
I don't know.
Gaps.
You'd have to look at his notes on the website.
Well, there's two ways of doing this. The traditional way was continuous. That's when we use film. But digitally now, people just typically take successive short exposures and stitch them together, basically.
I think you
So I
can
don't
see
know
with
what he
the
did.
airplane how long each exposure is.
Yeah,
Okay,
it's
so he was doing that.
Yeah,
Yeah,
he was
okay.
definitely doing a digital approach and stacking them.
Yep.
Anyway, what I'm trying to show with this picture is that the stars look like they're going around and around. It's actually the Earth going around, but there is a point in the middle, and we're going to talk about that, the North Celestial Pole. And this is my first, I don't know if you can see that I'm holding a book here, but this picture is on the screen. I bought this in the summer, and it's kind of like when Chris went through the handbook. He went through every week I don't know if I'll do this every week because I get interested in doing other things. But what this author has done is done really an excellent survey of all of astronomy, but with these example stars. And it's a new way for me, at least, of how to introduce astronomy. And chapter 1 is Polaris, which is a very good idea. So I'm going to more or less follow the book. But let's start with where Polaris is. Here you see Ursa Major, the Big Bear, or the Big Dipper, we call it. And here is the Little Bear. And as many of you know, if you take the 2 pointer stars and go 4.5 times along, you get to this star here. Now, in our light polluted sky, these 7 stars are very visible, but when you get to the Little Dipper or Ursa Minor, you can see this star and you can see these 2. And so often you're just looking for the star which is close to these 2 over here, and you just kind of got to guess that those ones are in the middle. But it is very, very useful to do this, and it's usually the first thing when people are learning their constellations in the Northern Hemisphere. It's the first thing that you'll learn.
Randy,
Yes,
go back.
go back.
I question your notation or depiction that this is a straight line, because on the celestial cushion, it would not be a straight line. So,
There you go.
okay.
In any case, oh, yeah, I know that who is it who loves this book so much? Gary. Anyway,
I do as well.
when Gary was talking about how he loves to give this book to people, I found this in a used bookstore, and it's an excellent book. It's a very nice introduction at a very different level than the history of our universe of 21 stars. But it's quite delightful, and for what I want to show now, it's beautiful. H.A. Ray, for those who don't know, is the author of Curious George. But he also was an amateur astronomer, and he did this excellent book. Okay, so here's the deal. You've got the Big Dipper points to the pole star. Okay, and the Big Dipper goes around and around, but the pole star stays in one place. This is another way that he shows it. So if your umbrella is showing you what the sky looks like, then as it spins around, so each one of these pictures is 6 hours. Every 6 hours, the stars go around a quarter circle. Now, it's not that the stars are going around, right? It's the Earth that's going around, and you're just looking at it. And they're staying fixed. We, without feeling it, are going around, and we're going around a particular point in the sky, and that is the North Celestial Pole. So
We're also going around the South Celestial Pole.
oh, yes, but I'm not there.
2 points.
Okay, so what? Dave was there last week, so he could have seen the South Celestial Pole.
It's not an obvious place.
But it's not as easy. It's not as easy as in the north. Okay, so what is this globe here? This is not a real globe. This is, what do they call it? The celestial sphere. But you got to pretend that there is a ball around you, wherever you are. It looks like, and the stars are dispersed all over in 3 dimensions, but we can't see that. What we see is just positions on the sky, and you can pretend that they are on a single globe. And you look towards the north, and you would get a point that is invariant. And what's kind of cool is as you move on the Earth, the globe goes with you, but it changes. Where the stars are is different. So if you see here, we've got the polar bear and the seal. If you're up at the North Pole, the celestial pole is straight over your head. We are here at 49 degrees. In this picture, he did it at 40, fine. And it's as if everything is on a tilt. And if you happen to be in where the Galapagos, say, and you look at where the north is, it's going to be horizontal. And so I find this very difficult, and I have to keep reminding myself how it works. So the Earth is spinning around on its axis, and the stars are so far away that you can't see the, as you spin around, you don't actually see the stars wobbling, but what you see is it looks like all of the stars are going around this point, and depending on your latitude, it's going to be either vertical or where we are kind of halfway up, or at the equator, it would be actually horizontal. I think this is remarkable, and they figured this out a long, long time ago. This was something that, they knew the Earth was a globe back in Babylonian and Greek days. There was none of this flat Earth stuff. Okay, it's very important. So it's in all sorts of flags like Nunavut or Alaska, or places that think they're the North, like Minnesota, because Minnesota is north if you're in the States, it's south if you're in Canada. Anyway, it's in all sorts of flags. It is the North Star. But it hasn't always been the North Star. That's the weird thing. It's only been about 500 years that it's been close enough that Polaris, so the tip of Ursa Minor, has only been around the North Celestial Pole for about 500 years. Because the Earth is wobbling. Okay, so if this is the path that the Earth takes around the sun, then the Earth is tilted by 23 degrees, and that 23 degrees over 26,000 years wobbles around. And so the effect of that is, if you were to talk about where the North Pole is in in only 12,000 years, it would be Vega, one of the very, very bright stars up there. That would be very practical. Or Deneb in only 8,000 years. That would be awesome. But right now, instead of a magnitude 0 star, we have a magnitude 2 star. That's not bad. Okay, but this has been known for a very long time, and I'm showing you these pictures that I took in December when I was in Rome. I did a pilgrimage to the Santa Maria degli Angeli e dei Martiri. And I did talk about this back in January, and it'll come up into other talks, but in 1702, they put a hole in the wall, and if you're looking north, the sun projects down on the floor. And so this is the Italian astronomer, oh my goodness, something Mundi, Cosimundi, something like that. And he's written several articles about this, and he happened to be making measurements the day I was there. So we're watching at the winter solstice or near it, the sun crossing this north-south meridian line. But what they did when they built this thing, they also put a hole on the south side, and you're supposed to look up at some of the bright stars in the north. And in particular, you can look at Polaris, and if you put your eye at this star here and look through that little hole, you would be looking straight along to the north celestial pole.
By looking south.
No, there you'd be looking north. So yeah, good question, Les. So in the south, there is a hole, and the sun comes in and it crosses at noon every day this meridian line. But they also put a northern gnomon. So gnomon is usually, it's the word that means the stick in a sundial, but in this case it means the hole in the wall. And what this is representing is where Polaris is each hour. So each one of these stars is an hour. There's 24 going around. And a thing that I read, Sigismundi, that's his name. This was not new science in 1702. They knew very well the precession of the Earth, the wobble of the Earth, and the reason that they put this in stone on the floor was to show how this church, and by extension the religion, is established for much longer than your, 70 and 10, the human life. What you see here in Roman numerals, so you see MDCCXXV, so that is 1,725. So I put what all of these circles, what they've been labeled, and you see that it goes from 1700 up to 2500. This is 800 years of the evolution of Polaris as it goes very near the celestial pole. This is 1 degree, this circle here. And we just, by funny coincidence, happen to be in the century when Polaris is closest to the North Pole. And, how big is this? I mean, it's a couple meters, maybe 3, from where the North Celestial Pole is to where Polaris would be at any of these times. And so I read somewhere that it wasn't used as the North Star more than 500 years ago. It was too far from the north. And people, like when I orient my equatorial mount towards the north, I just do it by eyeball because I'm looking at the moon. You don't have to be very accurate. But for you astrophotographers, it's actually really important that your mount is perfectly aligned with the North Celestial Pole. And if you aligned it with Polaris, you'd be out by 3/4 of a degree. And so they make these gizmos that go into your mount. Anybody who has a fancy mount, an EQ5 or 6, something like that, has this sort of device, and you can align the like this part of the Big Dipper, and then you know where Polaris is going to be compared to where the North Pole is. This octans, that is if you're in the South Pole. So this is a South Celestial Pole picture. because these stars are aligning up here. Okay. Anyway, it's something that amateur astronomers have to deal with. That Polaris is not at the North Pole, and worse luck, it's even changing with time. So, that's chapter 1. But it turns out that Polaris, as well as being near the North Celestial Pole, is a really interesting star. This is a 2023 paper, but it's funny. When you look at papers about Polaris, they all have a similar introduction. So Polaris, which is also called Alpha Ursa Minor, because it's the brightest star in the Little Bear. The North Star needs little introduction. I love this sort of thing when the author of a scholarly paper writes colloquially. Because of its brightness and location only 45 arc minutes from the North Celestial Pole, it has been an invaluable navigation beacon for centuries. Not millennia, for centuries. It has also been the subject of numerous scientific investigations since the mid-1850s, when its brightness was discovered to vary in a periodic fashion. Polaris is a yellow supergiant. It's an F, so only bad astronomers forget generally known mnemonics. So it's just one category over from the G class, which is the sun. Polaris is a yellow supergiant. That's interesting. And a classical Cepheid. That's interesting, albeit a somewhat unusual one for its short period, very close to 4 days and low amplitude, currently about 0.07 magnitude in V, which means green. Another characteristics of its variability. Polaris is also a triple system. There's so many interesting things. Anyway, let's go take a look at these in detail. So, first of all, it's you could call it a triple, but it's actually a binary. So Polaris, and they've known about Polaris B for a good long time. Polaris is a magnitude 2. Polaris B is somewhere like 8, 9, somewhere like that. So it's a telescope thing, and they go around each other over 30 years. But then they discovered that Polaris A actually is a binary itself. There's this little guy, AB, that's right next to Polaris A. So that makes it a triplet. It's crazy difficult to measure its distance, even though bistellar distances is not that far. But it's tricky because it's in this binary, and it's just too bright for things like the astrometric satellite called Hipparcos and for Gaia. The sensors saturate at something like magnitude 7 or 9. Anything brighter than that, they figure they'll be able to figure out the distance other ways. What actually Gaia did is it found the distance to Polaris B, that dim one, and then they worked out the orbital thing, and so they could work out how far away Polaris A, the real important one, is, because it's just too bright. So they're pretty well settled. It's at near 500 light years away. Now, I'm not going to go into the temperature luminosity curve today. That will come up as I go through this book. But the stars along what's called the main sequence are most stars, and they're burning hydrogen, they're turning hydrogen into helium. But this red arrow points to this guy, shows that the Polaris it's yellow, it's the same color as the sun, but it is way, way brighter. It's like 1,200 times, over 1,000 times brighter than the sun. It's much larger, and so it is called a yellow supergiant, and it's in this thing called the instability strip, where you get all of these stars which are transitioning from being hydrogen burning to helium burning, and they're going, whoa, 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 whoa. And that gets to be very useful because, oh yeah, here you see over a couple of periods, the brightness going up and down. And this is in the form that they call a Cepheid, because it looks like the type variable star in the constellation Cepheus. And what's very important is the Leavitt relationship that shows that the intrinsic brightness of this sort of star is directly, linearly related to the, what do you call it, to the period, how long it takes for it to go wow, wow, wow. And that it really is changing its size. It's going bigger and smaller. It's oscillating. But Polaris A is the closest Cepheid variable to Earth. And so when you're using these variable stars to figure out how far galaxies are, and then they look at those galaxies and look at supernova in the galaxies, and they use this as the scale of distances. It's all dependent on understanding how far away these close by Cepheid variables are. But the problem is that it's not absolutely a normal one. There's some funny things with it, with how it's going wow, wow, wow. And so what you usually see is these curves with Polaris and then without it. They do it both ways because they're really worried that it has too much weight in the measurement of this this curve. So they're very, very cautious using it. It is very close, but it's also a bit weird. And the other thing that's weird is it's changing. There's, as we were saying, they've got measurements going back to the 1850s. And so when they're looking at the pulsation period, look at how many decimal places. It goes between 3.964 and 3.972. So we're in, parts per thousand difference in how long it takes for this star to go bigger, smaller, bigger, smaller. And then there's the other really weird thing that there seems to be no data for 15 years. And I don't know what that's about. You can always see Polaris. Polaris is in the sky in the northern hemisphere 24 hours a day if you're using a radio telescope. For some reason, there was 15 years gap of data. Okay, so I'm just going to close with a bit of Shakespeare, because it is so many poems and plays and stories use the North Star as a metaphor. And one as important as Shakespeare did so. So this is the third act of Julius Caesar. He's talking to the senators. I could be well moved if I were as you. If I could pray to move, prayers would move me. But I am constant as the North Star, of whose true fixed and resting quality there is no fellow in the firmament. The skies are painted with unnumbered sparks. They are all fire, and everyone doth shine. But there's but one in all doth hold its place. And he's going to be killed in a couple of scenes, okay? So, what is it? Pride comes before the fall. So remember, Polaris is not constant.
Is that called foreshadowing? I'm getting nervous, Randy.
There, that's my story.
That's lovely. Thank you very much. All right. Natasha, would you like to speak next, please?
Actually, why don't we let Chris go first?
All right. Chris Gainor, you're up.
So this is, oops, the mute button is still on. Okay, so first of all, I want to apologize because I prepared this for our Wednesday meeting, and around dinner time, a friend of mine had fallen ill and had to spend a couple of days in hospital, and I sort of had to help get him sorted out just as the meeting was getting going. And when you're in that situation, you have zero control over what you can do or can't do. And anyway, so it wasn't a very enjoyable evening. And then the city of Victoria, of course, was encouraging people to help out their friends in hospital in the form of traffic tickets, even though it was like 8 or 9 p.m. when there was nobody there and I got the ticket. Anyway, enough of that. So I'm going to talk a little bit about some of the things that are going on in space since I last gave a report. Let me see. I'm just going to get my slides up here if I can. Okay. And so for the U.S. space program, it's been kind of an unparalleled, just a unprecedented year. I'm just going to start off by saying that generally it's not the matter of partisan politics, and well, I'm not going to be talking a lot about partisan politics, but there's politics here of various types. But for example, when President Kennedy wanted people to go to the moon, or wanted to send people to the moon, people from both sides, Republican and Democrat, voted in favor of that. Not everybody, but yeah. Actually, the ultimate kind of bipartisan project was Hubble. When I was working on my history, I noticed that Hubble kind of became an official project around 1977. And that it actually wouldn't have happened without the participation of both the outgoing Republican administration of Jerry Ford and the incoming Democratic administration of Jimmy Carter. So Hubble was a little different. You couldn't say President so-and-so did this because there were actually two presidents on a couple of different sides. So, but anyway, and then more recently, the space program is operated in a similar fashion. It's not, it hasn't been a big partisan thing. Even when, even in the first administration of President Trump, it was I really have nothing critical to say about the way things were run during that time. And I think the ultimate proof of that is that even though he made some changes from the time of Barack Obama, when Joe Biden came in, the NASA space program continued almost, it was almost an almost seamless change from one administration to another.
It changed quite a bit, Chris.
Well, it did change.
Yeah, they started looking at climate change and all sorts of non-space stuff.
Okay,
there you go.
can you just please? Uh, there was some questioning about that, but it actually did not change very much between Trump and Biden, including climate change. So now we are talking about today and the second administration of Trump, and there has been a lot of changes, which I'm going to be talking about, but we don't really know at this stage where we're going. Except, for example, there is a clear trend away from climate change. And I'm not going to be really talking about climate change very much in this thing, except I will point out that NASA's view of having spacecraft looking at that are based on the idea that Earth is a planet, like the other ones, and that it is best observed from space. But we're going to be talking about some other things that are going on. And so earlier this year, it looked like, the inauguration speech was talking about going to Mars. It looked like Elon Musk was going to be very influential in what was going on. And Jared Isaacman, who you see in the upper left there, was going to be the administrator of NASA. And by the time I gave my last report in May, Isaacman was out as the prospective administrator of NASA. Elon Musk was out, but there's been a lot of talk about cutbacks to various programs in NASA. And today the situation is rather uncertain. In the early months of this year, we had the Janet Petro, who was the head of Kennedy Space Center, was the interim administrator. And more recently, this summer, Sean Duffy replaced her as acting administrator of NASA, and he is still in that position. Sean Duffy is also the Secretary of Transportation, so he has two jobs. And he comes from a background, various things. I'm not going to get into it. He's been a host on Fox Television and various things like that. And more recently, he named Amit Kastreya as the associate administrator, who is probably running NASA on a day-to-day basis. And he actually has a background as kind of within the space program, running exploration programs. So, and he doesn't have a political background. But anyway, this is what's going on now. A permanent person to be administrator has not been submitted to the Senate yet. So we don't know who will ultimately be running NASA in the remainder of the 4 years. A person who is very influential in the running of NASA is this fellow here, Russell Vought, and he is the head of the Office of Management and Budget. His predecessors have often had a lot to say in the running of NASA. His role, I would say, at the present time is rather unprecedented, but it's it's hard to tell where it's going to go. I actually showed this slide earlier this year. This was in the spring when the budget was brought down. This is what President Trump had to say about what was going on, and I'll just let you look at it here. And this was kind of a more skeptical view of what was going on. This is a view from the NASA Watch website. Now you notice that I've scratched out a couple of things here. Those were originally being cut in the budget, which involved about a 25% cut in NASA's budget, which would make it smaller in real dollar cents than it did in 1960 when President Eisenhower was in office and before President Kennedy came in. But during this summer, the what's known as the Big Beautiful Bill went through Congress, and it basically restored much of the Artemis program and the Gateway Space Station, which Canada is involved in. One of the reasons why Jeremy Hansen is going into going around the moon in Artemis 2, hopefully in a few months, is because of Canada's contribution to Gateway. So Gateway with the Big Beautiful Bill is back. The Artemis program was going to end after Artemis 3, which in theory would be a lunar landing. Now it's a bit more indefinite. But there've been a whole set of cuts in the budget that came from the Office of Management and Budget for NASA, and so the question is, where is NASA going right now? So Artemis 2 is going very well and should fly early next year, possibly in April, perhaps a little earlier. But there's a lot of concern that the next voices that we hear from the lunar surface will be speaking Mandarin. Former NASA chief that's quoted here is a fellow named Jim Bridenstine, who is the administrator of NASA during President Trump's first term. So he's not a disaffected Democrat. Whether or not that happens, I guess we'll have to see. Let's see. I'm just going to speak very briefly about where things are at right now. So Congress, both houses of Congress have passed tentative budgets for NASA, which would not contain 25% cuts, but would be roughly the same as last year. But they have not got a fully formed bill through the Congress in which they both agree, which is part of the U.S. budget process. So right now, the Office of Management and Budget is telling NASA to operate as if these 25% cuts are in effect. And even if they are reversed tomorrow morning, there will be casualties. Contracts have been canceled. and people have either taken buyouts or have been laid off. But it is possible that within this month, Congress will pass a new budget, and then we will see what happens, because some of the things that are going on within the administration right now are really pushing the envelope in terms of past practice and even whether they're constitutional or not. So it could be that next month NASA's budget will be restored. There will be some cuts, as I said, because of what's already happened, or it may be 25% less. Today, or actually, I was just attended a briefing by the Planetary Society about this, and they are very concerned, and they've used a lot stronger language about things, not partisan, but anyway, a lot. They're very concerned about what's going on, and it could be a big change for NASA that would be, that would lead to things, cuts in various programs. So as I promised, I'm not going to talk about stuff like climate change, but for example, the astrophysics budget for NASA under the OMB budget would be cut 67%. A number of space telescopes would be shut down. A number of scientific missions not related to climate change would be closed down. Mars programs would be closed down. But we have to see what is going to happen, what the final resolution of this situation is. And of course, it's hard to tell where this is coming from. The fellow at the Planetary Society who does this full time, he's baffled about the background of some of this stuff because, for example, President Trump has said did not change, make huge changes to a lot of things in the space program, at least in the general direction in his first term. And there was lots of rhetoric like, we're going to plant this flag on Mars and things like that, keep on going to the moon, things like that. But and no mention of cuts to science until this budget came down. Russell Vought, who I showed you a little earlier, is known to be very much against all sorts of scientific endeavors. Cuts to science are going on across the United States government in all sorts of areas. Somebody at this briefing I attended said, well, what does this guy have against science? And the guy was a little bit baffled. He said, I don't know. Perhaps a scientist stepped on his dog or something, or it could come from sort of a bad feeling coming out of the pandemic. But anyway, that person has a lot of say over what's going on in NASA. So I think I will leave this. I'm going to talk about some other things that are not so difficult as this. But the next few weeks are going to be very interesting, perhaps very unhappy, and we just got to fasten our seatbelts. NASA is by far the largest space program in the world. China is becoming more competitive. The Russians are not that big a player because of their war. Europe is a big one, and Canada even on a per capita basis, we spend a fraction of what the Americans have on NASA. So anyway, we will see what happens to NASA's scientific programs, but I'm going to talk about a couple of other things. Elon Musk is not an influential figure in the U.S. government anymore, but he's still working at SpaceX and getting the Starship program going. And in theory, Starship could be used to take the next American astronauts to the lunar surface from the Orion spacecraft, which is part of Artemis. And during the summer, there were 3 Starship launches where the upper stages all failed. And the most recent Starship, which was Flight 10, just flew a little under a month ago, was pretty well a complete success. And this is a photograph when it was coming back to Earth. They didn't want to pick it up intact. They just wanted it to splash it down in the ocean. So Starship seems to be going again, and that could lead to the next American lunar landing. Elon Musk is very big on using this to take people to Mars. He has a very ambitious schedule, but of course, he has to deal with things like the limited launch windows for flights to Mars. But that's an important thing that happened this summer. A couple of things. There's still, even though there's, I was talking rather gloomily about certain scientific programs. There are things going on. In a few days, the IMAP spacecraft is due to be launched on a Falcon 9 rocket, and no, I've just forgotten what IMAP stands for, but it's an important scientific satellite to kind of get a sense of I believe how the solar system interacts with the sun. And then I came across this photo at the right here of a pretty amazing picture of a solar flare from the solar telescope in Hawaii. And perhaps the most one of the most important events over the summer was the beginning of the operations for the Rubin telescope, and this is the what it got of the galactic cluster in Virgo. And Rubin, it's actually they're still kind of commissioning it right now, but it's going to be taking regular photos of much of the universe. It's located in the Andes, if my memory serves me right, it will be making a lot of discoveries. Particularly amazing when you think that it's on the planet Earth. Even with its initial photographs, they were able to find roughly 1,000 asteroids that had not been previously discovered before, because they showed up in time-lapse photography from Rubin. There was a TV special when the first photos were revealed, and which is on YouTube, and I would urge anybody who's interested to watch that. And then, of course, this object, which is coming in from outside the solar system, it's going to make its 31 Atlas. There's still some argument about what exactly it is. It seems to act like a comet. So it's making its closest passage to the sun, I think, just right at the end of October. Although its greatest visibility from Earth, depending on what it does, maybe after that time, closer to Christmas. And I just kind of a final thing, the RASC Almanac, which many of us have, is coming out in a new name where it's being called the Night Sky Guide, and it's will soon be available. RASC will be selling some of it, but it's available. It's actually published by Firefly Publishing in cooperation with NASA, with RASC, and it's available from Amazon. So I will leave that there. And like I said, I'm going to be I may be here next week, but after that I'm going to be away for a little while. Well, I take a little vacation, but when I come back, we'll have to see what's going on at NASA. So thank you.
Thank you, Chris.
Thank you, Chris. That's a great update. Natasha, would you like to go next?
Sure. I have two very tiny things, very short things. I'm just going to share my screen. So it was fun to hear Chris talking about Artemis. This was not what I was going to speak about. I just wanted to quickly show you. I got a boarding pass for the mission, and I love when they do this kind of public outreach. I have one for the Parker Solar Probe and another one for, I don't know, I lose track of them all. But anyone can go on their website and get the boarding pass, sort of fun thing if you know any kids who are interested in astronomy or space. And what happens is they embed your name on a memory stick and it goes on board the craft. So it's fun. So I'm going to stop sharing that one and share what I was originally going to talk about. And it's something that all of you know a lot more about than I do. And I've been spending some time with the wonderful Observer's Handbook. So I look at, have a cup of tea and read a section, and I get the biggest kick out of Roy Bishop. I don't know Roy, and I guess some of you, does anyone know Roy?
Yes.
So, I mean, he has an amazing way of writing, and this is a brief excerpt from the chapter on rainbows and other sky phenomena. And it just caught my attention because he has a way of describing things that's particularly, I think, sort of stops you in your tracks. So he was saying that although rain and sunlight have been part of Earth's environment for over 4 billion years, colored rainbows occurred quite recently with the appearance of animals possessing color vision. So our visual world with its brightness and colors occurs within our skull. Nevertheless, by some feat of mental projection, we think our visual world coincides spatially with the outside world. And thus we confuse the neural rainbow with the external rainbow. So the eye does not detect the colors of the rainbow, the brain creates them. And we are part of the rainbow. So
that's great, Natasha.
I'm on a scientific level, I'm sure most of you understand these concepts, but for a layperson, this is kind of shocking. So, and I understand that Chris, you used to go through the handbook and speak regularly on certain segments. That might be something to revisit at some point because there's some real jewels in there. So that's it. I just wanted to share that quickly.
Thank you very much. All right. Reg, what would you like to say?
I'm not sure if I can say anything. I was signed in and I had to load an application. We'll see if it works. I'm going to try and share the screen if that's allowed.
Certainly.
And go here.
It works.
Sort of does, but weird stuff's coming up. It might be a disaster here.
I think you need to allow it first, though.
Oh, I don't know.
Well,
okay.
Yes, you need to allow it. That's your new operating system.
Okay, thanks
catching you up.
You might be able to get me through here. First of all, I want to thank Wyman for sharing that interesting information about the beautiful Aston Martins visiting the Dominion Radio Astrophysical Observatory. And let's see here. So that, whoops, just a second, I blew that. Where are we going? Okay. So this is a thing called spaceweather.com. And one neat thing about it is that they have a watch for T Corona B Borealis, which some of you might recall that David Lee has been patiently waiting for it to blow up for some time now. So I look at this pretty much every day, and if I see it rapidly, the magnitude changing, I'll give David a call. What I wanted to point out on this thing, they have all sorts of numbers. But one of the numbers they have is the radio sun, 10.7 centimeter flux. And that indeed, basically they have the sunspot cycle here. This is on the Space Weather Prediction Center. And this is the solar radio flux at that level too. And they correlate fairly well. And it was actually in 1946 during an eclipse, they were measuring this radio signal. And it disappeared during the eclipse, and it indicated that the signal definitely was coming from sunspots or something on the surface of the sun. And 1946, they used an old radar, surplus radar dish in Ottawa, and they set up this thing of monitoring the solar flux every day, starting in 1946. And then in 1990, they relocated it to Penticton, where Brian kindly mentioned that he was aware of this thing, and we even saw a picture of that. So I think that's kind of nice. But if you go down to the bottom of this thing, and if you're desperate for Canadian fame, in the fine print, they have down here Penticton, BC. That's the source of the 10.7 centimeter radio flux values. So this goes way back, but that has been going on for a long time and is considered a very important long-term measurement. And it shows the importance of having these long-term very stable observing programs going on, and it just came up from that. So I wanted to mention that. And then the other thing here, the mention of CHIME. How do I do this? I start from the start. Okay, so this was a little thing that I put together. Fast Radio Cosmos, Vicky Caspi, she gave a lecture, and the lecture is at this link here, and she talks about the Fast Radio Cosmos, and it was called the Ewan Lecture at Queen's University. So it was quite a high profile thing, but it featured the CHIME site. So it's, as was mentioned earlier, it's located at the Dominion Radio Astrophysical Observatory, just south of Penticton, and it started its operations in 2017. and fast radio bursts were just a little quiet sideline. But it was so successful that the Gordon and Betty Moore Foundation donated $11 million to add 3 smaller outrigger telescopes. One is in Heritage Mining Limited, 100 miles from Penticton. Then Green Bank, West Virginia, and Hat Creek, California have also got similar discs. And by putting them together, they can get a much higher resolution for locating where these fast radio bursts might come. The way that the CHIME antenna was designed is it has a resolution of about the diameter of the moon right now. And this will make a much finer measurement for that. So that's something to look forward to. If you want to learn more about CHIME, I did a deep dive in 2017 and wrote an article that goes into fairly gory details about the physics and the technology of how they expect to measure the expansion rate of the universe. And I found it quite interesting. You may not find it be so fascinated. So, but if you want, there's a link here, and it's in our website, and you can just pull it up and read that. But the other thing I wanted to do was talk a bit about the Star Party. One of the signature events of the Star Party this year was the invasion of smart telescopes. They started at the church, and they infiltrated the whole field. And Chris Gainor, he set up his smart telescope right next to mine. My thing. So we were both looking at the North American Nebula, and I finally processed that data. And so I finished it this afternoon. I just wanted to show this. So Chris, these smart telescopes, if you haven't seen them in action, are absolutely fabulous. And I only complain about them because I feel like the guy who spent all this money buying a really good tape deck just before CDs came out. You know what I mean? We're kind of out of sequence with all the latest technology. So, but this is my picture of the North American Nebula. I don't know if you can see it there.
Wow.
Pretty good. So, yeah, this was taken using a stupid telescope, not a smart telescope. My telescope was 61 millimeters in diameter, and a little bit bigger than, I don't know what the aperture of your telescope, Chris, is. Is it about the same?
Oh, yeah, I guess so.
Yeah, at any rate, that's 37 minutes of data stacked up there, and just using a DSLR. So you don't need a really big telescope to have fun and get beautiful stuff in the night sky. So I didn't really know if I was looking at the right thing, because I had some guiding issues with my system. But it wasn't until I added all the pictures that something emerged, and I was quite thrilled with that. So at any rate, I don't know if you've got yours available, Chris, but he had results much faster than I did. I'll leave it at that.
So how many images do you have there?
I have 27 1-minute images. No, it's at 37.
Anyway, so they're 1 minute, and you did it. That's fantastic.
Yeah, they're just in PixInsight, nothing fancy here. And
did you just Reg? Did you just do kind of a regular kind of processing, or did you pull out the stops?
Okay. First of all, there's a lot of stars here. I didn't use any of this evil black magic where you can erase stars and do stuff like that.
Okay.
This is kind of a vanilla processing of things. There's a lot of beautiful but evil technologies being applied these days to process the images. And this is fairly sanitized. I think I did use a thing called noise exterminator, but other than that, it's just basic stuff. So I'll leave it there.
I'll just make a couple of comments with this unistellar I had. I did get a couple of nice images of various things, but we were both shooting at the North American Nebula, and I think I took an exposure of kind of a similar length of time, and I was not happy with the results I got, and I think what Reg got there is vastly superior to what I got, at least in that case. So I think there's still kind of limitations to those things, you know. So, um, you know, I got that telescope as a bit of a recognition of my limitations, but I still think there's plenty of room for good old-fashioned craftsmanship, like we just saw with that image from Reg. So,
So Chris, I think you probably could benefit from the same thing by just taking your images from Unistellar and processing them in a similar fashion that Reg did. So you may get closer.
yes, yeah, perhaps.
I think your aperture is similar, and I think the technology's there, and it's it's far less painful to basically you're doing pain-free astronomy with your device there, Chris. But just today, PixInsight released a series of videos to assist people with smart telescopes to draw the stuff into the PixInsight and help process them and make even better images. So the PixInsight is realizing that this is a real thing, and Chris, you and many others are at the leading edge of it, the vanguard. So congratulations.
That's really interesting, Chris. I'm going to be doing a presentation about the smart telescopes when I host in November. So I'll collect all you guys that have smart telescopes, and perhaps you can show some images.
Yes, I did. I did post a couple of images I got at the Star Party on my astrophoto gallery, and I got a good one last year too of the Lagoon Nebula, I think. But and that's there too. But yeah, that would be good. But yeah, it's an interesting tool, but I you know, I still think there's very much a place for good old fashioned you know, or such as it is, of course. I'm so old now. I remember when everybody was hypering Tri-X and all that stuff.
Well, like many items in technology, you know, there's benefits and drawbacks, and it's got certain, you know, positive features, and certainly a lot of things can be done better by other methods.
Well,
So
I
yeah,
certainly remember the transition between film and the digital realm, and I I used to swear that it would never replace film, but slowly but surely it improved and improved to the point where you just couldn't say that anymore, right? In fact, digital was better.
Well, Wade often brings his C-Star 50 up to the VCO, and we have great fun teasing each other about it. But his ability to capture really beautiful images is just mind-blowing, and it is just joyous to watch this come in. I will say, if you're a bit more interested in smart telescopes, Richard S. Wright has written an article that's in the latest issue of Sky and Telescope, and he does a survey of all of the various ones and the history of their evolution. Something to consider.
Thank you very much. Dave Payne would be next, but I don't see Dave. I believe he has gone to other lands. So, is there anyone who has anything else to say? I notice Lori's not here tonight. David,
But
I'm just
Marjie,
yeah.
she is the host next week, and so and I will not be here. So please think of nice things that you would like to do. We haven't had a report from Edmonton forever, so
I haven't talked to anybody up there for.
We'll talk to
I've
somebody
been
this
away
week.
for a month.
anyway,
Too bright.
do think of content for next week so that Larry isn't hanging in the wind. This has been just awesome, all the variety of things that we had tonight. I just thought that was so cool. But yes, you were going to say, without Lori there, we should David.
I was going to ask David if there was anything he knew that that we might want.
There are a few
Yeah.
things that are going on. As you probably know, the FDAO and RASC are jointly hosting the next part 2 of NOVA. So the thing that hallmarks the second version of NOVA is that we've decided to take people that live and breathe certain parts of the program. So, for instance, Randy's going to join us for an evening to talk about the moon. Chris Peirce is going to talk about the sun, and there's some other people as well that are going to come by to sort of augment some of the material that NOVA has. Overwhelming kind of overload in terms of the response to NOVA. We're fully booked with two people on the waiting list, so it's proven to be extremely popular. One thing that we will try to do this go around is wherever possible, we're gonna make sure that we don't skip any kind of real world kind of operations in terms of the material that we're covering. We may have to do that with additional sessions, like for instance, with the sun, we were kind of scratching our heads. How are we gonna, get some, like some observing with the sun when the sun isn't going to be around at the time that the NOVA course is on. So we're still trying to figure that out. We might just have some sessions during the day or something like that. That may not work for everybody, but we're going to do our best to do that. So other than that, I don't know if there's much else to say, except there likely will be a NOVA 3. So we'll be doing, I don't know if it's going to be a repeat looping on top of part 1 again or something else. NOVA actually was quite a large set of lectures. We had a lot of kind of extra kind of sessions in NOVA as well. And for instance, I didn't do as many of the standard NOVA courses, but I did participate in groups that did things like light pollution and astrophotography. So there's a whole astrophotography unit that we've never done, and it's possible we may take segments of it. We may pull things out of it. I don't really know yet. So yeah, lots of things. If people really have some ideas of what they would like to see in terms of workshops, that would be wonderful. I will mention something. Dan Posey asked me on Saturday night when I was up at the Star Party whether this would be a good opportunity to reignite some interest in citizen science. Now, I know we've tried to do that in the past, and we never really could get that off the ground. But I actually have a project that I am involved in, and I guess by proxy, I guess the center is involved in as well. I do have a what we would call an ancient piece of technology. It's actually an analog photometer. I think I may have mentioned this. And I recently, with the help of Tom Calderwood down in Oregon, he's with the AAVSO. I'm also a member of the AAVSO. And through his help, I have restored the photometer that our center owned. I didn't realize that it was missing so many pieces, but when I started looking at the instrument and describing it and showing it to Tom over Zoom, he said, "What about this piece? What about this piece?" And then I suddenly realized the thing that we've had in our possession was missing a lot of pieces. So through his help, I've actually, I would say I've restored most of it now. I've redone a little bit of the wiring. I've repositioned or reconfirmed where the reticle is. The display appears to be working properly. We've had it on the VCO's instruments. We had it on the Takahashi a couple of weeks back. With Reg's help, I was able to see numbers churning on the display. So I'm very hopeful. Just to mention, I think we briefly mentioned how photometry or measuring magnitudes, like nowadays we are kind of only able to measure really dim objects now because of the fact that our cameras are so sensitive now that we would not think of using cameras to sort of measure things that are really bright. And I'm talking about things like Polaris would be considered bright. The variable, which is the prototype signature for the variables that we will be studying during the survey, is actually Alpha Cygni, and of course Alpha Cygni is Deneb, and it's a very bright star. So many of the stars that we're going to be examining are like that. In fact, another star that is a variable is Rigel, for fact, and it is, of course, very, very bright. So all these objects are kind of off limits for new equipment, but totally appropriate for this older technology. So this photometer is vintage in the 1980s, and it will be perfectly suitable for this. So once I calibrate it with some known stars and make sure that it is truly working, then I guess we will be able to engage. We'll be able to say, take direction from the surveyors, and if they want data on certain stars at certain times, then we should be able to comply. So I'm really excited about that. I will show you more stuff as time goes on. I'm actually in a process of building a data logger right now. Tom really recommended, rather than laboriously recording the dates and the times at which I make the observations, that instead I should kind of patch right into the electronics of the photometer and actually extract them through one of their streaming ports. These devices, again, were relatively crude, but they had a streaming signal that came off of a port on the device. So using some knowledge about Arduinos, which are microcontrollers, and a data board, I should be able to sample the stream that actually comes off of that data area, and then actually decipher it. Like I'll have to take the stream and kind of slice it up afterwards. It's not really a lot of work. I know the format of the stream, so I should be able to just take the stream and just using very simple scripting, I should be able to extract all the components. So yeah, it's quite exciting. I get to get my hands dirty. So it's been a lot of fun. And if anybody wants to know more about the project, please let me know. I can supply you with the original paper, which is the premise for doing this survey, if you're interested.
Thank you, David.
And I think that's about it. Brock, is Brock still here? I don't know if Brock's
Out
still.
of time too.
Yeah, it's 9.
We have to close
Oh,
out here.
okay. And anyways, Brock is busy restoring the 16, and at some point, I'm sure he will talk about that.
Okay. Thank you very much. Thank you to all. It was a wonderful intellectual evening, and that's a wrap.